In this video, we shall learn how to solve equations involving surds using equality property. Before we do that, can you recall that we can simplify expressions like this to this form, where a and b are rational numbers and square root of n is a surd? Note that when we put the two expressions together, they are equations with the left-hand side equal to the right-hand side. So, let's first look at an equation like this. At this point, it is important to note that the unknowns in this equation and subsequent ones are rational numbers. Now, what can you observe about the surds in this equation? Yes, these two have the same surd. This means that these must be equal to each other because they are the only terms with the surd square root of 5. Thus, by comparing their coefficients, we know the value of u. Now, how about these two? Well, they must be equal as well, because these are the only terms that are rational. Now, let's try a similar question. Like in the previous example, we can compare the coefficients of the only terms with surds to find the value of t and s2, since these are the only rational terms. From these two examples, can you see that we can equate the rational terms and compare the coefficients of terms with the same surd to find the values of the unknowns? This is the equality property of surds that we can use to find unknowns in the equations involving surds. Next, let's see how we can apply this to this question. Now, did you realize that in order to apply the equality property, we need to simplify this expression to this form? So, let's expand and simplify to get this. Now, what can you observe? Yes, we can equate the rational terms to find h and compare the coefficient of the terms with the surd square root of 2 to get the value of k. Next, let's take a look at a similar question like this. As before, let's simplify this expression and we will have this. Again, we can equate the rational terms to find n. When equating the terms with the surd, it is important to take note of the coefficients, hence, we will be able to find the value of m as well. Next, let's apply what we have learned to this question. Now we know that we can express this expression in this form. By doing so, we will be able to apply the equality property to find the unknowns. Thus, let's multiply the expression by this, and simplifying it further will give us this. Now that we have simplified this, do you know what to do next? Yes, that's right. Observe that these terms are the only ones that are rational. So we can find the value of e. And similarly, we can equate the terms with the surd square root of 5 and compare their coefficients to get the value of f. So far, we've been able to find the value of the unknowns directly by equating the rational terms and terms with the same surd. Is it always the case? Let's find out in this last question. Like before, let's first simplify this expression to this form by expanding to get the first two terms, followed by the next two terms. Further simplifying the terms will give us this. But wait, why are there 4 terms instead of 2, like this? Think about how we can simplify this further. Well, we need to group the rational terms together, as well as the terms with the same surd together, and put a bracket to group the rational terms and terms with the surd, which is equal to this. Now, are we ready to compare? The answer is yes, but do you know which are the rational terms? Yes, these are the rational terms, and we will have this equation. So we will get the value of p. Similarly, it is important to note that 3p minus 10 is the coefficient of the surd square root of 3. Thus, we will have this. Did you notice that this equation has both p and q? This means that we need to substitute the value of p found earlier into the equation to get the value of q.